In this lesson, we'll focus on how to convert between the different quadratic forms. This diagram hopefully can help you remember how to move between each one, and we'll try to move from one form to another in one single step. Sometimes there are techniques where you can, if you want to move from factor form to vertex form, you can go to standard and then from standard to vertex. But it's good to learn how to convert to and from each of the forms, and then it's going to help you find different properties. Sometimes a question gives you something in factored form and you need to then convert to vertex form. Sometimes you start off writing in vertex form, but the question wants it in standard form, for example. So you need to learn how to convert between all the different forms. And remember, each of the form gives you an easy property to figure out. So standard form gives you the y-intercept easily, factored form gives you the x-intercepts easily, and vertex form gives you the vertex easily. We will use the same running example from the last video where we went through all the properties of quadratic, because it's gonna hopefully make sense how we convert from each one. So let's start with 2x squared plus 4x minus 6. If we are in standard form, and I'm going to show how to move from factored form to vertex form, the method you're going to use to move between these forms, they're not new methods, they are methods you have used in the properties video before. So if you want to move from standard to factored form, first of all, always remember that in all the forms, the a value is always the same. So always make sure you have your a value. So in this case, my a value is 2. So I know if I'm going to move in factored form, I know it's going to start with a 2 and then something. So if I'm going to factored form, I will just factorize this normally. And in this case, first I can see I have a GCF I can factor out. And I have 2x minus 3, and then I can use sum and product with what's inside, two numbers that multiply to give negative 3 and add to give 2. Those two numbers would be positive 3 and negative 1, and I shouldn't forget the 2 here, so the 2 comes here. And this is exactly factored form. If we come to vertex form, what you need to do is find the vertex. So I know my a is equal to 2. I'm going to keep that on the side. The vertex, going back to the properties video, you should know how to find the vertex. In this example, the vertex is negative 1, negative 8. And therefore, now that I have the vertex, this represents my h, this represents my k value. And I can just directly plug in the values a, h, and k, exactly how the vertex form looks like. So a x minus h squared plus k, exactly where those letters are, so 2x minus 1 squared, and then minus 8. And to simplify that, it's going to give me x plus 1 squared minus 8. There is another method called completing the square, and it works slightly differently. It relates to how you factorize quadratics, but I'm not going to go through that in this video. But if you search online, you will see some people explaining that in order to move from standard to vertex form, you can use completing the square method. If we start off with vertex form, and if you notice, it's the same vertex form that we got here. So what if I start from vertex form and I want to move to standard form, which is the easiest form to move to? In order to move to standard form, you have to expand and simplify. So just taking my vertex, and remember, this means that x plus 1, the bracket is being squared. That's not how you do it. Be careful. You don't spread the square. It's x plus 1 minus 8. Expand these first, just so that you keep track of your numbers. Expand these first, but keep your expansion in a bracket. So x squared, this will simplify to this. I keep them inside the bracket because I am mindful of the fact that I have a 2 on the outside that will now multiply with each of these. I'm still not touching the negative 8 because I need to finish off the brackets and the multiplication. So this is 2x squared plus 4x plus 2, and then I take the minus 8. I can only simplify plus 2 minus 8, which will give me a minus 6. So I wrote my quadratic in standard form. If you want to move from vertex form to factored form, so think of what the form requires. This form requires the intercepts. So if I can find the x-intercepts when I'm in vertex form, I can then write them in directly here. Given that, again, what the a value is still the same, which is 2. So if I look here and I want to find the x-intercepts, again, go back to the properties video. We talked about how to find the x-intercepts. It's about solving this, and we started to move things around, and we ended up with x equals to negative 3 and x equals to 1. So these are my p value and q value, and we said it does not matter which one's p and q unless they have stated something like, oh, p has to be less than q, but we didn't, so it doesn't matter. So now if I take factored form, which is ax minus p x minus q, I can directly plug in my letters. This is 2 minus p, so minus 3, and then minus q, which is minus 1. Minus 3 will end up being x plus 3, x minus 1. So I have now written it in factored form. And again, go back to all the previous slides. You'll notice we're all getting the same exact answer because these are all equivalent forms of the same quadratic. And then the last form is the factored form, which is what we just got a few seconds ago. Again, from factor to standard, this is quite easy. You just expand and simplify. So if I'm going to expand, I will first expand these two brackets first, keeping the 2 outside. So this will be x squared minus x plus 3x minus 3. I will simplify further. This will give me plus 2x minus 3. And then I will multiply in the 2. So 2x squared plus 4x minus 6, which is what we had here. If you're moving from factor to vertex, again, think of what this form requires. It requires the vertex. So all you have to do is find the vertex. When you're in factored form, the vertex is found by doing p plus q over 2. This is the x coordinates of the vertex. My p value and my q value are negative 3 and 1. So the x coordinates is negative 3 plus 1 over 2, which is minus 1. And then the y coordinates is found by substituting this negative 1. We've already done all of this in the previous video. Minus 1. And this will give you minus 8. So my vertex is negative 1, negative 8. And again, looking at vertex form directly, so this is 2x minus, my h value is always the x coordinate of the vertex, which is minus 1 squared, and my k value is always the y coordinate of the vertex, which is minus 8. I will simplify this. It will give me x plus 1 squared minus 8. So if you notice in all the examples, it's all coming full circle, so they're all the same form. So 2x squared plus 4x minus 6 is actually 2x plus 1 squared minus 8 is actually 2 x plus 3x minus 1. So I'm just going to pause in this diagram to hopefully it's clear now how to move from one form to another. And when in doubt, for example, if, again, I've mentioned this in the beginning, if you forgot how to move from factor to vertex form, you can always move back to standard and then standard to vertex form. Or always think, what does the form require? If the form is called factored form, you need to factorize. Or intercept form, you need the intercepts. If it's called vertex form, you need the vertex, so you need to find them. So just focus on what the form requires and find that property and convert to that form.